Okay, so we should be streaming. Perfect. Okay, so get that. Okay, perfect. So yesterday is calculus, and today is calculus. So trying to get into the zone of where we were at yesterday. So yesterday we sort of looked at, or we were watching through this video. We got an entire 2 minutes and 21 seconds in. And I was really trying to get the conceptual understandings as they were being talked about. And then we made some Anki cards, which we'll be reviewing. And then okay. Yeah, so we made some Anki cards we'll be reviewing. And then once I get into that right state of mind for being here, then I think I might go ahead and try to see if I can get some of these answers to the questions that I came up with. And I think there is also a lot more information that can be put into Anki so far. Like, I think there's some good nuggets here. Specifically, from what I remember, the ones regarding like how mathematics is seen, how calculus is seen by a mathematician. It's hard to get sort of an inside view of things sometimes, and so that's really good. And obviously the inside view provided by ChatGPT actually will be quite similar to like a mathematician. But like, I guess what I'm saying is, if I were to read like this introductory book, but instead of it being for mathematics, it would be for calculus, then I think I would get a fairly similar idea. Obviously, the book would be more detailed probably, but you can approximate that by like a simple question like this. Okay, so yeah, I think we'll go ahead and start Anki first, and then I'll just put this here. I think I want to make sure. I want to zoom in a little bit more just so these are more visible. I'm not sure if it's quite awesome that yeah, we'll see. I'm gonna do some testing to see what would be good for size here. Okay, perfect. So as you can see, I haven't done my Anki cards entirely today. But we'll start off by going over the cards that we did do. Okay, so calculus is a branch of mathematics that deals with the concepts like derivatives, integrals, and limits, and is concerned about infinities, not infinities. Okay, that's the best I have so far. There's a branch of mathematics that studies continuous change through limits, derivatives, and integrals in infinite series. Okay, so infinities is part of that. It's essential tools for understanding and modeling real-world phenomena. Okay, so I think the big ideas there were studies continuous change, and then through those four things: limits, derivatives, integrals, and infinite series. What is the symbol? What does the integral symbol look like? This one is the large S. Okay, the derivative operator is d over d of x. It represents the operation of differentiation with respect to x. Yep. A derivative in calculus is an operation for a function that so it takes a function and transforms it into a function that, given a value, it will output the slope at that point in the function. A derivative in calculus measures how a function changes as its input changes. It represents the function's rate of change or slope given any point. Okay, so I'd like to clarify this because I said something slightly different. And this is actually I thought I had today. So I was thinking about integrals and derivatives according to, or in the context of functions. So like a function is just a regular function taking inputs and outputs, and if we have the derivative of that function, this would be taking an input of a value and an output of the slope at that particular point within a function. I guess also a function would be an input, though I'm not sure if that's entirely a good way of conceptualizing it. So I'm going to clarify just momentarily. So because I'm not sure if whether a derivative is the thing that takes us to like a derivative function, or if the derivative, oh, actually, no, it probably is the derivative function. Because I assume that when I have the derivative, that I then have a function that takes inputs, like values, and then outputs a slope. Or sorry, yeah, outputs a slope. Could you... I'm going to look how to do voice to text in Windows. Windows H. I am wanting to know a bit about derivatives. Could you help me or walk me through an example derivative? Additionally, I'd like some clarification on the wording behind it. From what I know so far, when you have a function and take a derivative of it, is it the case that I get a new function that is called the derivative, and this derivative takes inputs values and then outputs the the slope at a given point? Question mark. Or is it better to think of as is it better to think? Think the derivative as taking input value and function and outputting slope at a given point for that function. I think I will get better at the voice text, but it is nice because for things it can be quick. Okay. Okay, so it looks like it is the case that a derivative is a function of a function. Yeah, and this function, you could think of it as like a different form of, we'll just say a default function, that takes inputs and returns slope, and the inputs being a point on that function and the output being the slope at that given point. Okay, I think I'm comfortable with that. Okay, a limit is an idea within calculus, or rather, it is I think it's a measure of what occurs in a function as you approach a certain threshold or point. Is that right? Describes the value of a function approaches as its input nears a certain point. Okay, so that's not quite what I was looking, or that this is different than what I talked about. So I described it in the concept of what's occurring in a function, but it is the case that we're more interested in the output. So we'll just go to the next one. Okay, so the integral symbol. Oh, this needs to be edited. Oh, shoot. I've been using the reversals wrong. That is a rip. Okay, so I'll have a lot of cards to edit. I should have checked that before I dove deep into it. I just recently implemented the reversals, and I thought they functioned differently. So here it shows that like it gives this one, and the reversal would be the answer to this one. And I thought it was this one, and the answer is this one. So literally every reversal card I've done, I'll need to adjust. So we'll just go through that one. Yep. The derivative operator, yeah. Okay. Okay. Oh, let's see. So calculus is a branch of mathematics that studies rates of change, and does so through the use of infinite series, limits, integrals, and differentiation. A limit is so a limit is a study of a function, or I'm struggling to find the right word for this. So a limit is when we see what the value, or like a value becomes, or the output of a function becomes as the inputs reach a certain threshold. Describes the value of a function approaches, or what the value of a function approaches as its input nears a specific point. Okay, I think that's good. Okay, so we will finish that there. Okay, perfect. And I think I'm going to increase the size here just a little bit. Okay, so I think we'll then, let's see. Okay. Let's bring my I'm interested in learning a little bit about limits within calculus. So I guess this is also a question about derivatives and integrals, but no, this is just a question about derivatives. I have a question about derivatives. My understanding of finding a slope in my, limited mathematics is that you take 2 points on the line and then determine the slope based on those 2 points. And this is done for linear functions, period. For derivatives, how is it the case that we can have or find the slope given that we only pass in a single point? Oh, okay. Hmm. Interesting. So, it says that you're right about a straight line. You need 2 points to calculate a constant slope. However, for a curve, the slope changes at each point. The derivative is defined as the limit of the difference quotient. Here, the quotient initially uses 2 points a and a plus h. Taking the limit h as it approaches 0 makes the 2 points infinitesimally close, yielding the instantaneous slope at a. Okay. So I think instantaneous slope is a new term as part of derivative. So I'll add that as well. I'll just put make a small list that I'll delete later that I will be adding cards for, so don't forget. Okay. Additionally, I am going to be wanting to figure out the syntax here for what we're going on, like this lim, and then it was described here, but I'd like to pull that out into an Anki card. Okay, so it seems like this is just something that can be done. We specify as we're approaching infinity, that we eventually we're able to still arrive at an instantaneous slope. Okay. All right. Okay. Dun, 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 dun. Yeah, so in the context of derivatives, what is the slope of the tangent line? Could you draw a picture of it? So it outputs Python. Oops. Okay. Rip. Okay. Okay, I've just asked them for some JavaScript that will run in the console. Okay, creating canvas, a border, putting it to the doc, or to the, okay. Okay. So we should see this below. There we are. Okay. Perfect. Okay, so the tangent is this line. That is the slope at a given infinitesimal point. Perfect. Okay, so I think so this language is associated with this derivative. I remember tangent in trigonometry, but I haven't touched that in a long time. So I might have to bring some cards such that I have that language as well, or create some cards that I have such that I have that language as well. Okay. How can integrals and derivatives be considered opposites? Okay. Okay. So it does look like that okay. Okay. So, interesting. I think this will be really good to grab, but it just seems to be the case. Obviously, I'll be able to understand it as I dive more into it. That when you derive a function, or let's see. When you derive a function, if you integrate the derivative, then it becomes the function you began with. And then opposite ways, you can integrate something which finds the antiderivative and then derive it, and that would bring you to the original function again. Okay. I'm not sure what is meant by the last sentence. It says, yes, the integration finds the antiderivative, a function whose derivative equals the original function. When performing an indefinite integral, you add a constant since the derivative of any constant is 0. Okay, since the derivative of any constant is 0, it makes sense, because if it's constant, then it would have no slope. Okay, so it looks like an indefinite integral is something that's new. Okay, so I'm going to look more into indefinite integrals. So indefinite integrals versus just integrals, or definite integrals, I assume. Okay. Let's see. Okay, I think I'll go over the rest of this top portion here before we continue. Okay. Da-da-da-da. Okay, so looks like there will be some limit laws that are a thing. Also, actually, I think I'd like to put this above. Also, the fundamental theorem of calculus. Of calculus from below would be good to know. Okay, and then looks like for this, so computing limits. Okay. Okay, instantaneous rate of change. Okay. Antiderivative. Okay. Nice. So fundamental connection, appreciate the fundamental theorem of calculus as the bridge between the between differentiation and integration. Okay, that makes sense now. Okay, looks like there are different integration methods, and so we'll be doing those. Okay. Okay, I think I'm gonna skip. Well, I will grab. Well, let's see. I think I would like to grab... No, I think we'll return to this later. And I'll just grab this here of what calculus looks... Or what is the view of calculus... Or how is calculus thought of according to a mathematician? And I'll specify 2 points. So typically you want your Anki cards to not be like crazy complex, because when you're trying to retrieve something, if the retrieval is like 7 steps, it's just going to be awful to do. And so I'm trying to make this simple. I think knowing what calculus is like, or knowing how a mathematician views calculus, I think it's a very valuable thing, because then as I continue to learn new mathematics, then I understand the role that calculus plays within broader mathematics. And so we'll fire this one off. Let's see, another thing that is a good thing to do. So obviously LLMs can hallucinate, and additionally they also, so you want to be careful about that. But okay, perfect. Also they do have the context of like the entire internet, and so sort of doing a spot check by testing different models and what their answer is, kind of gives you an idea of if the thing I asked or the answer I received is like good. Well, let's see. We'll check Claude as well. Okay, okay, so I do kind of get the same thing here. So this framework bridges discrete and continuous mathematics. So this is... Oh, I don't know if I like this answer anymore. Okay. Okay, so... So all of these have connections between how calculus is used for understanding change. And the other ones... Yeah, this question is not as awesome as I would have liked it to have been. Maybe if I phrase it slightly differently that I can get a similar answer out. Okay. I think we will wait a little bit. Yeah, I'm not sure. Because I'd like to have Anki cards that, for a given answer, have like a definite for a given question, they have a definite answer. And so I don't super enjoy that fact that maybe I'll change it slightly more. Maybe also specifying connect to other branches. So also, how does calculus connect to other branches of mathematics? Let's see if we get something similar. Okay, so... Okay, so this is what we got here. Okay, so I can adjust this such that I would get this answer out. So in 2 points, I need to figure out, how is calculus thought of according to a mathematician. What is a good way to phrase this question such that I get that answer out? Because I could just append to it and say, how is calculus thought of according to a mathematician? Maybe both in use, and how it connects two other branches of math. Okay, so this should give me but one thing about this is that I'm already giving the answer here. Like, because the this rigorous foundation part is kind of saying that like calculus connects various areas of mathematics, and so adjusting the question to this would sort of make the answer, that portion of the answer, redundant. So I'm still kind of in a toss-up for how I feel about that, but I'm just going to go ahead for it. Where are you? Okay. Okay, perfect. Okay, so we are good there. And then we'll want to head back up there. I think I will be using this eventually, because at some point, probably after I finish this video, I'll need to figure out like what it is, or rather, what is the discrete set of concepts and discrete set of processes that an individual needs to be able to do such that they know calculus. And obviously there's like a lot of branches to calculus, and like probably a lot of different ways to apply calculus, but I'm sort of thinking from, if I were to take the class, like, and I was competent at the end, what would that look like? And so I will be using what ChatGPT says, and I'll also probably be looking at this calculus book I have. One thing that is just rough about like textbooks these days, or I guess paper textbooks, is they're like awesome to use, right? They're like, kind of feel one with the material, and using something physical is nice. However, it kind of blows that there isn't like a simple, way to grab the text into like a large language model to interact with it, where I could do that on a PDF that enabled that. So I don't know. Maybe I will and using a camera to take a snippet of it seems like a little extra, and not like a quick thing. Who knows? Maybe I'll think about that more. Okay, so let's see. So we'll add this card here. Yeah, I really should have investigated what this optional reverse thing did. I just assumed, and I literally probably have more than 100 cards that I need to edit now. So that's exciting. Okay, so let's see. So we're down to, in summary, blah, blah, blah. Okay, complementary perspectives, broader role of calculus. All right. Okay. Okay, so it looks like we are to that point. So I think we will continue in the video. Actually, we'll create this first. I think the limit laws, being that there's an S after this, there's going to be a lot, or I assume more than one. So I'll maybe keep that one there, but pause on generating that one. So I did describe that I'm building an application that will have like a portion of the functionality will be similar to Anki, and then there'll be a lot more on it. And as part of that, like, there is this sort of drudgery with creating cards that like like could be removed through implementing or like an integration with a large language model. So this time now is good to sort of get all my pains out in learning and figure out what would be like the most convenient thing to use, and most convenient and also still effective. Okay, what is the fundamental theorem of calculus? So we'll grab that. So what is the concept of instantaneous slope in calculus? I do want to make the connection. Also the tangent line. Oh, okay. Let's see. Okay, the tangent lines. Okay. So that is that already. Or I wanted to, in my answer, to connect the ideas of instantaneous slope being the same as the tangent line of the slope at that point. Okay. So we'll copy that and then add that of the tangent line. Let's see. I think he said it earlier. Let's turn back on the audio.
For calculating how much something accumulates over time. And we need to know that derivatives and integration, they're opposites of each other. For instance, we said that the derivative of a function f of x is equal to that into so at some x value. Now, limits help undefined to limit derivatives are functions that give you the slope of an original function at some value. So let's say if I have some function f of x, the derivative of f of x is known as f prime of x. Now this function here will tell me the slope of this function at some x value. It will give me the slope of the tangent line. So the derivatives.
Slope of the tangent line. So I was looking for that specific language. The concept of the slope of the tangent line in calculus. And the big idea with the Anki cards is that, like, yeah, it's initial investment, but all learning is investment, right? But doing these Anki cards enables you to not only be able to, let's see, I guess it enables two things. One, it will enable you to maintain knowledge of this particular thing if you continue to review your cards. And then two, and as part of number one, it will reveal to you if you've forgotten something. And that's a really key part in learning because you don't... when you've forgotten something, it's not often the case that you remember that you've forgotten it. And so by nature of you forgetting it, it's like kind of already gone. And so having Anki cards sort of reveals knowledge gaps or things that you've forgotten, so you can spend more time. And then by nature of the spaced repetition algorithm, where if you forget something many times, you'll see it more often. It sort of auto updates with that to help you remember after you've forgotten it. So very nice. Okay, so so we will add that. Let's see. And this indefinite integrals is a little bit out of my understanding so far, and so it may be that, like, depending on the vibe I get from ChatGPT's answer, I may hold off on that until I have a little bit better knowledge. One thing I do like to append to my questions is this less than 50 words, because that makes the responses short and perfect for Anki. Okay, I also want to be able to capture one thing I do not like about Anki is when I paste in, for whatever reason, I'm getting double of like these special characters. So next one, what is indefinite integration in calculus? Let's see. So in this answer, it mostly focused on what indefinite integration is, because we have like integration because it's describing a type of integration, indefinite integration. I would like to know what makes integration or normal integration different from indefinite integration. So I'm asking, if there are different types of integration, or are there just indefinite and definite? Oh, so I'm suspecting that there are probably loads of different types of integrations, depending on the differences in like the functions you use. That's like a shooting from the hip, but this may be like indefinite versus definite, maybe like a super category where it's like all integrations fall in these two categories regardless of what you're handling. Okay. Okay, so it looks like there are more things, but for now, I think just understanding them in the context of indefinite and definite is probably sufficient, because this looks like, I don't know. Well, it does say it's more advanced, so. Indefinite integration. Okay. So we will and the last one I would like to do is what's the difference between indefinite because I do understand, at least conceptually, that an integral of a function will return the sort of, or will return a function. Actually, I'm not entirely sure. So what I do know so far is that an integral returns. So I assume. That's actually a good question. So we have like a curve, right? And integral defines space under the curve. And so for an integral, is it like I specify this point here? Or is an integral like everything under the curve, and then I just like, I want like 60% of that, or whatever proportion. Okay. So I'm going to ask that, and then we will, or I'm going to ask the definite versus indefinite, and then, let's see. Yields a family of antiderivatives expressed as f of x plus c. Definite integrals calculates the net accumulation between two bounds. Oh, okay. Okay, so, wow. That's surprising. It's an answer to my question. So it looks like definite integrals are ones that are like specifying the integrals or specifying the area under the curve between two bounds. And then definite integrals indefinite ones are not that. So they yield a family of antiderivatives. So I'm not sure why it's the case that we get a family of them. It would seem to me that, or maybe, I'm not sure. So maybe indefinite integrals are, Okay, so maybe indefinite integrals are when I take an indefinite integral, it like hypothetically or conceptually returns the set of all antiderivatives that specify or that like exist within this function, because we're talking about like infinities, right? And so like each point of this curve like has like what you could think of as like or I guess in the context of, you know, limits and things that I've been like exposed to, like each point in this function has how would I say, perhaps a derivative, or like this family of derivatives that returns, there's like an infinite set of these things. And each of them specify just the tiniest little sliver, you know, like infinitesimally small portion that make up the entire thing. But actually, in contrast to that, if I were taking the definite, so I was operating towards that in that indefinite integrals, meaning we have like sort of indefinite number of, or let's see, I'm going to go back to make this more clear. So in my description, I was thinking that, maybe it's that indefinite integrals yield a family of antiderivatives, which is like an indefinite or like an infinite set under like that describe the volume under this curve at an infinitesimally small point. But it is the case that like even when I do a normal integral, a definite integral, like I'm assuming that I have to calculate like I would also in some ways return a set of these functions. No, I don't know if that's correct. If it is the case that we are taking like little slivers of this to and actually, I think I watched a Veritasium video on calculus, because this little slivers thing, I think, is from that. But if we're taking these little slivers to calculate the area under the curve, and this is more conceptually than actually, at least I understand, then, okay, at least conceptually than actually, then we will have an infinite number of functions. Okay, so there is I have a question, like there is a question there. So perhaps I will, looks like we're at time, and so perhaps I will just notate that question to make sure that I don't forget for learning more about it tomorrow. And then we will just wrap up there. Dun, 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 dun. Oh, well, Okay, so it looks like an indefinite integral is merely about calculating the family of functions that are defined. But definite integrals, I just want the net accumulation. Oh, okay. So, okay. Actually, I don't have my question anymore. So, well, I would like to understand more about the family of antiderivatives, because I assume when they're talking about family, like that's a big family. Like we have like an infinite family of antiderivatives if it is the case that like they get specified, at least conceptually, one slice at a time. Let's see. I'm just going to ask that real quick. Could you tell me about what you mean by family of antiderivatives? I am struggling conceptually with the notion of indefinite integrals, period, or perhaps I don't really understand them quite yet, period. I think... Yeah. Okay, we'll just send that and see what it looks like. Okay, when you find an indefinite integral, you're seeking an antiderivative. Okay, so I'm seeking a function instead of for definite integrals where I'm seeking a value. Any function f of x whose derivative is little f of x. I need to figure out how to say that. However, since the derivative of any constant is 0, f of x is an antiderivative. Or if f of x is an antiderivative, so f of x plus c for any constant c. However, since the derivative of any constant is 0, if f of x is a derivative, so is f of x plus c for any constant c. Since the derivative of any constant is 0. Oh, okay. So this is just saying, like, we can pretty much throw away this constant because constants are always going to be 0. This collection of functions differing only by constant is called a family of antiderivatives. Essentially, the indefinite integral represents all functions that, when differentiated, give back f of x, or the integral x. I need to figure out what the little f is. Could you... In words, how do I make the verbal distinction between the capital F of x and little f of x that you have above? Whoa. In words, how could I make the distinction between the capital F of x and the little f of x that you have above? Is a antiderivative the same thing as an integral? Why do we prefer calling it an antiderivative over an integral, if that is the case? Oh, okay. So, so it looks like between antiderivative and integral, because in definite integrals, like that actually yield values instead of yielding the set of functions or the family of functions. Okay, let me explain that thought. So the So we emphasize the antiderivative because the integral is like associated with since there are two different types of integrals, one being definite, meaning if I input something, I'm going to receive numerical values out, and then the indefinite representing the family of functions. So because that is the case, we emphasize the antiderivative. Actually, why don't I just tell ChatGPT this? Okay, so I'm going to restate to determine if I've got this understanding correct, period. So the reason why we call it antiderivative instead of identifying it as an integral is because there is a distinction between definite and indefinite integrals, such that the definite integral is one that returns numerical values, and the indefinite integral is a family of functions that, if derived, return the original function. Parenthesis. Left parenthesis. Hell yeah. Left parenthesis. Double check if that's correct. Right parenthesis. Because of this distinction between indefinite and definite integrals, we like to emphasize the fact that the antiderivative is the thing that, if derived, returns our original function. Is that correct? Please be very specific. If I'm close, identify so, and specify exactly what I'm missing. I don't want to be merely good enough. Okay, so yeah, your understanding is mostly correct. Here's a detailed breakdown. Antiderivative, a function f of x is an antiderivative of I really need a better way for distinguishing verbally between those. Okay, represents the family of all antiderivatives. Is the family of all antiderivatives one that have the same function but only differing constants? Okay, so that seems like I'm mostly correct there. Could, according to our last three messages, our last few messages, would you be able to write a set of questions such that if these questions could be answered, the understanding of the last, 5 or so messages of our conversation would be had? Okay, so I think I'll just grab these for next time. hopefully that has enough. I have enough context there to get back to that question. Okay, let's see. Why is an antiderivative called of a function called an antiderivative? Antiderivative and not an integral. Okay, perfect. I think we'll just stop there. And we will continue tomorrow. So, as for schedule, I'm going to be doing at least Monday, Tuesday, and Wednesday. And I think over the weekend, I plan on doing like an actual channel video. Or at least that's what I intend for, like, starting this up. So, there's that. But I think I'm actually not sure what is reasonable for time for streaming, but I think it's been great so far. And again, it may seem odd that I'm spending so much time on, like, without even, like, looking at the mathematics of calculus. But understanding things conceptually will make the mathematics of it, at least I think, much easier. Because if I have a good conceptual foundation, then there's a conceptual framework for how the procedures of calculus, or actually doing calculus, can, like, rest in, or how they can, or the conceptual framework enables me to have a understanding of, like, how the procedures will be used. Because that's, like, really having a good conceptual understanding is really important. I once chatted with someone who was a mechanical engineering student in a place that I lived previously, and I was interested in learning a little bit of, like we were just chatting, and I had some questions because I had, like, known about calculus, but I hadn't known much about calculus. And they were able to describe some things, but this person took a calculus class, but weren't able to describe, like, they described to a certain point, and then at, like, a point of my questioning, they weren't able to describe anymore. And I don't think I was questioning more than integrals and derivatives, because they described, like, these things are important in calculus, right? Yeah. So they weren't able to describe much more than, like, or they weren't even able to describe the fundamental concepts in calculus. And so that, like, just seems to show that, people will adopt the minimal, or people will learn the minimal needed, like, procedurally, in mathematics, or not always, right? But like, they won't have conceptual understanding, even though they passed a calculus class. So, or maybe they just forgot it. Okay, I think we will finish. I will see you tomorrow.